modulus of A plus B equal to modulus of A minus B given. Then prove that factor A is perpendicular factor B. So it is if modulus of A plus B equal to modulus of A minus B, then you have to prove the angle between A and B is 90 degrees. So the solution is like that. You can suppose A plus B to be R, because R is the resultant vector and their components are A and B. Similarly, R dash is the resultant vector of A plus minus B. A plus minus B, you can write A plus minus B. So what is given in the condition? Modulus of A plus B equal to modulus of A minus B. So you can write in place of A plus B to be R. So modulus of R equal to modulus of A minus B, that is R dash factor. So if you square this term, that will be R square. If you square the modulus on both sides of the equation, then you will get this. So on squaring the modulus, you will get R square, as because on taking modulus the vector sign vanishes, and on the right hand side also on taking the modulus vector sign vanishes, it remains as R dash square. So now see, R square can be written as R dot R. Similarly on the right side, R dash square can be written as R dash dot R dash. Else because you see, since A dot A equal to modulus of A modulus of B, and the angle between these two vectors A dot B, the formula is A B cos theta, that the angle between the same two vectors A and A is 0 degree. So it is cos 0. So A dot A, that you can break into A B as Y B cos theta. The modulus of A is A, the modulus of B is A, and the angle between these two vectors is 0. That is why it is cos 0. So you can write cos 0 1, that becomes A into A becomes A square 1. So we have A square equal to A dot A. So with this property we can write modulo R square equal to R dot A, and similarly R dot square equal to R dot vector dot R dot vector. Now we will write on the top, because there is no space at the bottom. You see, you can put the value of R. What do we have? Suppose to be R equal to A plus B. So we have put the value of R, it is dot, we are writing dot. Again we put the value of R, A plus B equal to, you again put the value of R dash, which you have already supposed, or what we have supposed, that is A plus minus means A minus B. Again dot is here, dot is here. And you put the value of R dash, it becomes A minus B. So don't be confused, it's not algebraical product, it's a dot product of the two expressions, because dot is here on the right hand side too, there is a dot in between two terms. So be very careful in carrying multiplications of the vectors, unlike algebraical quantities. Now you see A dot A, that becomes the property A dot A equal to A square, A dot V, A dot V, again B dot A, B dot A, B dot V, with the property A dot A equal to A square. Similarly, B dot V equal to B square, the vector sign vanishes. Again, similarly on the right hand side, you can carry the multiplication between A and A. It becomes A square, and A and minus B, that becomes A dot, because dot is there, A dot V. Now you have to multiply this two terms. You see there is a negative sign, so it will be b dot a. So b into b, that will be again b square, the scalar term, because the factor sign vanishes. You see a square, one term minus become positive. So b square on the left hand side and right hand side get cancelled. On the left hand side a square is on the right hand side a square get cancelled. So what, since factor product are commutative, factor or dot product are commutative, a dot b equal to b dot a, so we can write a dot b equal to a dot b plus b dot a as a dot b, because a dot b equal to b dot a. Similarly on the left right hand side a dot b minus, you can put the value b dot a as a dot b, because factor dot product is commutative. A dot b b dot a, you can put the as a dot b, so it will be twice a dot v. On the right hand side there is a negative sign, ab twice a dot v. So if we take it onto the right hand side, this will be very simple factor operations, factor addition and subtractions. You take this sum onto the left hand side, 2ab becomes 4ab, because it will be positive on transferring onto the left hand side, equal to 0. Now divide both the sides with by 4. It will be a dot b equal to 0. Now I would like to write the last line at the top of the board, because of lack of space. A dot b will be a dot b. You know the dot product, we have already got the formula of a dot b, that is ab cos theta equal to 0. Since a and b are non-zero vector, we have to consider to be non-zero vector. Otherwise, if it is 0, b is 0, you cannot divide 0 by 0. It's a meaningless, indeterminate. You cannot find the value. So you have to consider a and b to be non-zero. Otherwise, you cannot define the right hand side by dividing by a and b, because you cannot, 0 and by 0 is not defined. 0 by 0 is not defined. 0 by 0 is not defined. So you have to consider a, b, both are to be non-zero. So on dividing a by OB, AB on the right side, that depends cos theta equal to 0. So you know what is the value of 0 in terms of cos? That is cos 90 degree. That is cos get cancelled. We have finally theta equal to 90 degree. That was our purpose. What do we arrive at? Actually, the angle theta is 90 degree. That means we have to prove a perpendicular P, and we have broken this formula a dot b equal to ab cos theta. Theta is the angle between a and b, and we have all at the last shown theta to be 90 degree. That is a is perpendicular. That is a is perpendicular to b. So hence we have proved with a given condition that whenever modulus of a plus b equal to modulus of a minus b, the angle between a and b is 90 degree. So I hope all of you have got my explanations well, and let switch over to the next problem, very important problem.